Anything in C#, well, any object that is, that has a value has a data type, and that includes variables. It also includes return values from functions, both those built into the language as well as those you create, property values, and columns in a database. A typical C# program will work with a great deal of data, often from a variety of sources. And this data may be of similar or quite different data types. As a result, many programs have to meticulously change the data types to allow you to work with the data in a coherent fashion, particularly since in most cases, operations you perform on multiple pieces of data have to be the same type. Sometimes C# takes care of conversions for you. Those are called implicit conversions. And sometimes you have to explicitly do it, which are called, unsurprisingly, explicit conversions. When you declare a variable, you specify the type of data that it'll hold. So here's some code that declares a couple of variables, an integer units ordered, and I'm initializing that value to 100, and then a decimal unit price set to 24.5. And so this is the cost of each unit of whatever this product is. Now, I'm using the M here in order to specify that this is a decimal literal, because by default, the C# compiler will consider that to be a double, and it'll complain that I'm trying to assign it to a decimal. So I include the M suffix, and it does the right thing as far as figuring out what kind of data that is. Okay, so what's the total dollar amount of this order? Well, of course, it's the value of the units ordered variable multiplied by the value of the unit price variable. And units ordered is defined as an int. So it's seeing that as an integer value as part of the product right here. And then unit price is a decimal. So we have two different data types. And it's multiplying the values together. But what it's having to do is that C# automatically does an implicit conversion to convert the integer units ordered to a decimal value, because the result of the multiplication is going to be stored in a decimal value. That's how I'm defining total amount. It's a dollar amount, has to have decimals, and so it needs to be a decimal data type, or some sort of data type that can record decimal digits. All right, so this is an implicit conversion, and that conversion succeeds because it's what's called a widening conversion. In a widening conversion, the new data type, in this case decimal, is capable of storing all of the values of the original data type, in this case an int. So in other words, a decimal data type has a range of values that is greater than the range of integers. So there's no chance in implicit conversion of any kind of data loss. So that's what allows C# to do this as a widening conversion. Okay, so let's comment out this code and instead write the code this way. So now what I'm doing is I'm defining total amount as an integer. And as you can see, I have a problem because I have a red squiggly, and if I hover over the mouse cursor, it says cannot implicitly convert type decimal to int. An implicit conversion exists. Are you missing a cast? And so it's kind of hinting at what the solution is. So this conversion fails because it's a narrowing conversion. In a narrowing conversion, the new data type, in this case the int that I'm declaring total amount as, is not capable of storing all of the values of the original data type, in this case the decimal data type. In this case, you could lose data. If C# just went ahead and converted that to an integer, you could lose data, and so C# is protecting you from that kind of a problem. So this is one of the many ways that the C# compiler does everything in its power to help you write bug-free code. All right, so let's talk a little bit more about widening conversions. This is a table of most of the widening conversions in C#. So again, with widening conversions, when you're converting from the data type in the left column to one of the data types in the right column, then C# doesn't require that you explicitly write code. You don't have to explicitly do a conversion. Instead, the compiler will convert the data type for you. And you saw that in that previous example. All right, so interesting ones are that integers will convert okay to longs, decimals, floats, and doubles. And decimals will widen to float and double. And there's various others. Oh, and charns will widen to a string. Because again, the important point here is that there's no loss of data in these types of conversions. So for any other data type conversions, which are narrowing conversions, you have to make the necessary conversions explicitly in your code. In essence, you're taking control and telling the compiler that you know what you're doing. So be really sure that you do. So this often involves writing validation code that performs checks to make sure that you don't lose data. Sometimes you legitimately won't care about the lost data, but most of the time you probably will. Taking advantage of implicit conversions can be very useful in your C# code, simplifying the code that you need to write, but you really need to be careful with them. Mostly they're safe, since the compiler protects you from losing valuable data, but they essentially hide operations that aren't readily apparent when reading code, which can lead to misunderstandings about what the code is doing, which makes it harder to maintain the code later. So if you come back 6 months from now and read this, are you going to remember what your intention was, particularly if the domain of values in those variables has changed because there's been different system or business requirements. So because of this, a best practice is to always perform explicit conversions that make it obvious what code is doing, even when the C# compiler would otherwise perform an implicit conversion for you. And when you need to perform narrowing conversions, you'll always have to do it explicitly anyway. Okay, so let's now start talking about how you can perform explicit conversions. Now, even though C# can perform many data type conversions automatically, you should use the cast operator to explicitly convert data, the data types in your code. So I showed you an example of where the compiler will automatically make widening conversions for you. But it's a good practice to explicitly make conversions in your code. Your code will end up being more readable and self-documenting. And one of the ways to make that kind of a conversion is with a cast operator, which is simply the data type name in parentheses. So this is the one that you'll probably tend to use most often because it's the simplest, it's the cleanest, and so forth. So one example of that code that I showed you in the project of converting the type would be to include the cast operator, that's in bold, the integer in parentheses. So what this cast operator does in this case is it takes the result of the multiplication. So the cast operator is acting on the phrase or the expression that's within parentheses, the units ordered times unit price. So again, as that first example that I showed you in the code, the compiler is going to convert units ordered to a decimal value, multiply by a decimal unit price, and then take that result and explicitly cast it to an integer. This is a narrowing conversion. You could lose data. But the compiler is going to be happy with this because, again, you're telling the compiler, I know I could lose data. The range of values I'm not worried about. Just go ahead and cast it to an int. And total amount gets an integer value. Okay, and total amount gets assigned that value. Now, you could also perform an explicit cast of unit price to an int using a cast operator. Then the multiplication will be of two int values. So make sure you understand that. So units ordered is already an integer value. I could cast unit price, move the cast operator to inside the parentheses right in front of unit price. The compiler will cast unit price to an integer. There'll probably be some data loss because there's no decimal values unless all our unit prices are whole dollars. And then it's multiplying an integer times an integer. And the compiler has no problem assigning that resulting integer to an integer data value. But the thing here, though, is that depending on the original value of unit price, this could result in a different value assigned to total amount, because you could be essentially rounding off unit price before you do the multiplication, whereas the rounding off takes place after you've done the multiplication if you use the code as I currently show it here in the slide. Okay, so be sure to carefully think through how you juggle implicit and explicit casts. Okay, here I am back in the code. I'm going to comment out that previous example that I was talking about. And here's that code that I showed you in the slide. So again, what's happening here is that units ordered is in the int. That's how it's declared up here. Unit price is a decimal. The compiler casts this or converts it to a decimal value for the purpose of the multiplication. And then it takes the result of that multiplication and casts it to an int, and then assigns that value to total amount. And the compiler's happy. You've told it you don't care about the potential loss of data, and so this code executes. Okay, so let's look at some more examples of using a cast operator to convert from one data type to another. And all of these are widening conversions. Okay, so this widening conversions method here just calls a number of other methods that I'm going to talk about. Okay, so the first one is conversion operators. And here what I'm doing is I'm declaring a number of different data types: byte, short, int, long, float, double, decimal, char, and string. In this first example, I'm assigning the byte value 2, the short value 100. I'm displaying those out, and then I'm adding the two together and converting it to a short value. So again, this is going to take that short, add it to the byte value, and then takes that sum and converts it to a short and assigns that to the short value. Here's an example of doing a similar thing where you're converting a short value to an integer and adding it to an integer. So here's an example where I'm applying the cast operator to one of the variables, one of the operands in the addition, casting it to an int, and now I have two ints that are being added together. And then I display the result. Here's an example of converting an integer to a long. So this is a typical way that you would do this. So you would actually convert just one of the operands, explicitly converting that value. But just keep in mind that even though it's less of a problem with addition typically, in multiplication and other mathematical operations, where you put the cast operator could affect the value of the calculation. So you kind of need to play with your own data just to find out what works best. And then here's an example of casting a long to a float. And the result is a float value here. Now, an interesting thing to note about this particular example is that even though converting from a long to a float is a widening conversion, there could be some data loss here. The float can hold the value stored in the long variable, but it can't do it with the same precision. The same would happen if the long variable were converted to a double variable. Okay, so there's some issues with precision as well. Okay, so hopefully you get the idea of how to use the cast operator. And a lot of times it'll be a function where you write an equation, an expression, some sort of mathematical operation, as complex or simple as you want. The compiler will complain, and you'll have to do a cast in order to make the compiler happy. But what that's doing is, well, and you also need to make sure that if you're doing a narrowing conversion explicitly, that you're okay with the potential data loss. And most often you're going to be okay with the potential data loss when the range of values for the particular variables are small enough that it's not going to be a problem during the normal execution of the program. But you probably need to include some code to make sure. So make sure that a particular numeric value is less than 32,000, for example, and that way if it does exceed 32,000, that's an edge case, an unusual case, you let the user know, and maybe you let the user select whether or not that data loss is okay. So there's a lot of ways that you can handle that. Okay, and so you can pretty much get the idea. There's a few more examples here of casting to doubles and decimals and so forth. Now, up to here, the code has been converting one numeric value to another. But now I want to talk about this example right here. So in this example, I'm converting a decimal value to a string. So if I follow the pattern of the previous examples, I might try to write this line of code right here. So looks like it should happen just fine. I'm using the string type here, parentheses, this is a cast operator, and I'm attempting to convert that decimal value to a string value so that I can concatenate it with this ABC string. But if I hover the cursor over this cast, it says cannot convert type decimal to string. Okay, well that's kind of strange because you can convert just about anything to a string. You need to all the time. In order to display it in the console window, you have to convert all numeric types to a string. So what's happening here is that this is a special case in the .NET framework because the system.object object, which is the foundation object of almost all .NET classes, has a toString method that you can use instead. What's nice about it is that the method is overridable, meaning that you can write your own custom method that converts your own classes to a string however you like. So instead of this statement, I'm going to undo that change, get rid of that comment. What you can do is use the toString method there. And that happily converts the decimal value to a string, and it concatenates it together, and then you're able to display it. And then in this final example, it converts a char to a string, and it also uses the toString method there. So this one might seem a little strange because a char is sort of a string. It's a one-character string in essence. But you have to keep in mind and understand that chars and strings are distinct data types. So you need to convert the data, even though it should be blatantly obvious to the compiler what's going on. Okay, so I'm going to go ahead and run the code. I'll press F5. And I'll press B to run the widening conversions. And here you can see the result. Byte value is 2, short value is 100. They added them together. Short and an integer, integer and a long, long and a float, float and a double, double and a decimal, decimal and string value. So these are the last two examples I was talking about. So it converted the second value to a string and concatenated them together. And so it ended up being ABC and then the string form of this decimal value. And then finally, char value is A, ABC A.